Next set of reactions that we did with those associated with the group 2 or the alkaline earth metal cations right here. And what we did with those alkaline earth metal cations, the group 2 cations, where we looked at the sulfates, the carbonates, and the hydroxides. And of course, this is straight out of the A-level specifications. So let's start off with the sulfates. Okay, we took some copper sulfate, and I chose that because it's a nice pretty blue, and we added to that copper sulfate one portion of magnesium chloride, another portion of calcium bromide, and another portion of barium chloride. Okay, so the important things that we're doing here is we're keeping the anions constant and we're changing which cation we're adding in. So that's what happens when I add magnesium chloride to my copper sulfate. Absolutely no change whatsoever. It's still a beautiful blue solution. The blue, of course, got nothing to do with magnesium or sulfate. The blue is the copper. Now then, if I take some copper sulfate and I add calcium to it, now we see the formation of a white precipitate. Now it still looks kind of bluish because yes, there's a white precipitate in there, but it's not so dominant that it's overcoming the blue color. However, when I take another sample of the copper sulfate and I add some barium chloride to it, you can still see there's a vestige of blue there, but there's so much of that barium sulfate has precipitated out, it's kind of dominating out that blue color. So the sulfates become less soluble as you go down the group. So magnesium sulfate, no problem, it's soluble, doesn't form a precipitate. Calcium sulfate forms a bit of a precipitate. Barium sulfate forms a lot of a precipitate. So for the sulfates, the solubility decreases as you go down the group. Now let's move to the carbonates. And here are all three of them, magnesium, calcium, and barium carbonate. You can see that you have a white precipitate in each one of these. So as far as we're concerned for the A-level, all of the group 2 carbonates, all of the alkaline earth metal carbonates are insoluble. You can't see it nearly as well here, though I did try to sort of give enough of a background, but the solubility again, in this case, it will decrease as you go down the group. So therefore, the barium sulfate is less soluble than the calcium sulfate less soluble than the magnesium sulfate, but you don't need to know that for the A-levels. Okay, but anyway, so for the sulfates and the carbonates, the solubility is decreasing as you go down the group. So the magnesium is the most soluble, or the least insoluble in this case, and the barium is always the least soluble. Moving to the hydroxides, of course, there they are, magnesium, calcium, and barium. You can see we're getting a precipitate for the magnesium hydroxide, a precipitate for the calcium hydroxide, no precipitate for the barium hydroxide. Now I've sort of called this a gel. It's rather gelatinous. You can sort of see at the top there, it looks a little bit jelly-like. Magnesium hydroxide, it's insoluble, okay, but it forms this sort of jelly-like thingy. But anyway, magnesium, calcium, and then barium hydroxide is so soluble that it doesn't make the precipitate. So for hydroxides, the solubility increases as you go down the group. Okay. Last little thing we had you do was adding some extra hydroxide to these. If we added extra hydroxide to those, nothing happened at all, no change. And that is because none of these are amphoteric. Okay, so as far as the group 2, the alkaline earth metals, we're interested in sulfates. Sulfates become less soluble as you go down the group. Magnesium sulfate is soluble, calcium and barium not. We're interested in the carbonates, all of which are insoluble, although again the solubility decreases as you go down the group, or the insolubility increases, however you like to say it. And then finally, the hydroxides, the order is flipped. Barium hydroxide is soluble, calcium and magnesium hydroxide are insoluble.